Okay friends, in this video we'll talk about the context and the memory. So what the agent can see right now and how it remembers anything at all. So I will go back to the anatomy of an agent. So if you haven't watched previous videos, please go back where I in the initial videos explained about this diagram. So on the left hand side, if you can see, there is a long term memory section, and below it there is a context window. So context window is something that I am also referring to as short term memory and long term memory, as the name suggests. So we will talk about both of these memory and how it shapes our agent. So what can model actually see? The tool menu, the calls, the results, everything lives in one place. That is the context window. It is the model's entire field of view. It is not it's not in there. The model doesn't know it, and it's finite, which is exactly why agents need memory. Let's take both together. So you understand that what is context is actually whatever we want the LLM model to be visible from our full agent, like the tools metadata, like what are the results, what is the history, what is the user prompt, what is the goal. So all these information that we want to make readily available to agent LLM, it is all stored in the context window or short term memory. So what it generally contains: so system prompts, the job description, rules to sorry tools, conversation history, the back and forth so far, tools definitions, the menu of tools, like the metadata of the tools, like we discussed in the previous video, retrieved memory. So this memory is limited, so we have another memory that is called long term. So sometimes we need to pull some details from the long memory section, so that is the retrieved part over here in the context window. Latest tool results: so every time the LLM makes a call to a tool, so tool produces some results, so that result is also present in the context. So you can see that how everything is available in context that we need to feed to LLM for every pass of the loop. So window is finite, it only holds so much measured in tokens. Every message, tool result, instruction takes up space in the window. On a long task, the window fills up and something has to give up. So this is important actually. The context window is always finite. I will tell why. So this single limit quietly shapes almost every design decision, because there is always a limit of the context window, and this is where the cost comes in. So what happens is, majority of time the context window is almost full, like, because it is getting lots of text and data, and there is also a free space. But what happens when it runs out, then it has to drop some of the older data to make some space. So two kinds of memory: short term memory and long term memory. Short term is the context window, whereas long term is the storage, which is outside the window, which is outside the context window. Outside means actually that the storage that is not presented to LLM or sent to LLM in each call, right? So this storage, long term storage, could be database, or it could be vector database, or some files, but it is never presented to the LLM model directly. Finite window is exactly where long term memory has to exist. We call a context window as finite. It will always be finite. So we have another memory that is bigger, that is outside, so we that has more storage than the finite. So short term memory, the context window, the running scratchpad, everything happens in this task right now. It's just context window, the conversation and results, instant to use. Model already sees all of it on every pass, but it's temporary, it's limited by the window, and it's gone when the task ends. It's consider it like a sticky note on your desk. So it's just in front of your eyes, so that you are aware of it. whereas long term memory is the storage outside of the window that is not presented to the LLM. It's a file, it's a database, or a vector store. It doesn't take up window space until it is needed. When relevant, runtime retrieves the piece and drops it into the context. So you can very well visualize this thing, and it also makes sense you, because there is always a finite amount of memory that is presented to LLM, because it is costly. So every time a window, finite window is long, more and more data it has, so it consumes more and more tokens. So we want to avoid that, minimize that. So that's why we have a bigger memory section, long term memory separate, and there is a communication going on between short term and long term memory, and whatever it needs it picks up from the long term. So it's a filing cabinet, and holds far more information than your desk. So pulling right piece from storage into context is a whole skill of its own, because the thing is that in agent, when you are developing, you see the components, right? These components are very pretty easy, like it's just a tool that is doing some search, whereas LLM is the brain that is doing all the computation, all the decision making. But when you architect agent, is that's the crucial part, that is how you manage the memory, because memory is something that directly impacts your cost. So how they work together: long term storage feeds the window is what the model actually reads. Long term memory, lots of facts and past work, and context window is only what's needed right now. And then LLM reads the context window always. The skill is keeping the window small and relevant. So friends, think it in the terms like, when you are a developer, and if you remember past few years without the LLM and chat GPT and AI, you remember that when you always try to optimize, you always try to do more with your resources. If I talk about the server, you enhance the performance, and what impact does it make? You improve the performance, the compute capacity that you have, you can do more work with it, and that eventually is saving you cost. So here the cost is saved in terms of how much memory you are able to manage efficiently. That's the context memory. Why this shapes everything? So it's something that I just told, like it keeps the context store and retrieve the core memory trade-off, when to summarize the history so it stays small enough to fit. So history has to be managed, like we need to keep on summarizing so that it remains small. Which tools and instructions are worth in the space? That's an important decision, because what you want to keep in the context memory and what you want to keep in the long term memory. So there has to be a trade-off and decide it carefully. Cost and speed. A fuller window means more to process every single pass. Context and memory in one breath. So the context window in the field of view, it is not in there. The model can't see it. It's finite, measured in tokens. It fills up. Old content falls off. So finite means that if it's filling, you have to summarize it, few things, maybe history you have to squeeze, and then when you have reached to a squeeze limit, maybe you have to let some content go that is no longer in use, or maybe that landed first, maybe the older results, because the older results were there, and loop is now in the later stage, so it has already made a decision based on those tools. So it may vary based on use cases, but it's very important thing to manage. Short-term memory, the window, instant but temporary. Long-term is retrieved into context when needed. So short-term memory, and it's finite, and it's the context window. So in next video we'll talk about like planning and task decomposition. Thank you. Bye bye.